I'm going to talk about similarity, okay? Let me start by making it clear what similarity means. Two geometric figures are similar if they have the same shape. Okay? Two geometric figures are similar if they have the same shape. Every square is similar to every other square. Every isosceles right triangle is similar to every other isosceles right triangle. Let me quickly add a note of clarification. Similar shapes similar figures do not have to have the same size. All right? Now, when we defined what it meant for two figures to be congruent, there you may remember that it was important to emphasize that both figures had the same shape and the same size. But similarity is, the requirements aren't as stringent as for congruency. All right? So let me give you some examples of similar figures. So I already mentioned a few of them. So squares. Any two squares are similar. All right? Any two isosceles right triangles. Remember, isosceles triangles have two sides that are the same size. So something like that. And similarity even applies to more complex shaped figures, like suppose you had this polygon. It can be said to be similar to a bigger version of itself. Something like that. Okay? Now, how can we tell if two figures have the same shape? Well, at least for polygons, there's a straightforward way to confirm that two figures have the same shape. Let me mention that right now. Okay, so two polygons are similar if all corresponding angles are congruent and the ratios and all the ratios of corresponding side lengths are equal. All right, so let's see an example to try to make this more clear. I will draw two triangles and then we will continue. I'm almost done. All right, so I've drawn two triangles ABC and triangles XYZ. And I've also identified the measures of the 3 angles of each of the triangles and the 3 side lengths of each of the triangles. All right. Now, to confirm that these 2 triangles are similar, we would do the following. First, we would say, okay, is angle A congruent to its corresponding angle on the other triangle, which would be angle X? And yes, that is true. Is angle B congruent to the corresponding angle on the other triangle, its corresponding angle, and that would be angle Y, and that's true. Is angle C congruent to, for angle C, we have to ask if it's congruent to angle Z, that's the corresponding angle on the other triangle. Okay, and regarding the side lengths, let's take the ratio of the hypotenuses, so 2/6. So now we ask ourselves, does that equal the corresponding ratio of with respect to the shortest sides of each triangle? So does that equal 1/3? And the answer is yes. And furthermore, let's take the ratio now of the longest legs. Let's find the ratio of the side lengths with respect to the longest legs of each triangle. So that gives square root of 3 divided by 3√3, and all of those fractions are equal. The angle pairs there are all congruent, so therefore we can say for sure that these 2 triangles are congruent. Okay? And this same procedure will work with all types of polygons, okay? Pentagons, hexagons, squares, all right? Quadrilaterals, parallelograms, well, you name it. Okay, let's finish by having you try to use what we've just talked about to try to do the following proofs. Prove that all equilateral triangles are similar. Okay? So pause the video and see if you can do that proof. In other words, see if you can think of an argument of why that must be true. Okay, so I'll go ahead and show you an example of an argument you could make to prove this. So equilateral triangles have all angles congruent and all sides congruent. Another word for that is we say that the triangles are regular. Okay? So equilateral triangles all the angles of all equilateral triangles have a measure of 60 degrees. You can see that by the fact that all the angles, the angle measures for each triangle have to add up to 180, and all the measures have to be equal. Okay? Now, no matter what the side lengths are, you'll see that the ratios of corresponding side lengths are the same. So let's say that the smaller triangle has side lengths of 2, and let's say that the bigger triangle has side lengths of 5. So all the ratios of corresponding side lengths are all 2/5. Okay, and this applies for any equilateral triangle, and so therefore we've proven that all equilateral triangles must be similar. All right, let's try one more. Prove that all regular polygons with the same number of sides are similar. All right, pause the video and try to do that one now. Okay, I'll show you an argument you could make. So, just like you have equilateral triangles, you have regular polygons. That's the same idea for polygons with more sides. So, the definition of a regular polygon is a polygon where all the sides are congruent and all the angles are congruent. So right away we've got the, we're almost done with the angle part of what we need to do. Let me show you why. So we know, or you might know, that the sum of all the interior angles for an n-sided polygon, the sums of the measures of all the interior angles of an n-sided polygon is equal to 180 degrees times n minus 2. Okay? So if two polygons have the same number of sides, then their measures of their interior angles add up to the same number. And since they all have to be equal, then if the n-sided polygon is regular, then each angle will have a measure given by the formula I've just written down, divided by n. Okay? So now we've established that all the angles, all the corresponding angles of any two regular polygons with the same number of sides are congruent. Okay? And then we know that for each polygon we have to have the same side lengths. So let's say the smaller one had a length, all the sides had a length x, and let's say the bigger one, all the sides had a length y. Okay? So the ratios of corresponding side lengths will all be equal to the fraction x over y. Okay? So for example, if x was equal to 2 and y was equal to 3, then all the ratios of all the corresponding side lengths would be 2/3. Okay? And so that proves that all regular polygons with the same number of sides are similar.